In this video, I'm going to demonstrate calculating an optimal product mix, also theory of constraints, using exercise 451 as a basis. So a setup of the problem is we have a company that produces two different types of toys, a standard deluxe. They give us the price, the variable cost, and the machine hours to make each individual unit. Machine hours is the constraint in this situation, and they have a maximum of 90,000 machine hours. Their fixed cost per quarter of 800,000. So they've got to determine how do they use those machine hours wisely. In the first situation, we indicate that the maximum sales that they can sell of either deluxe and or standard is 200,000, and that's individually. So let's look at how we can use those machine hours wisely and what that optimal product mix is. So my starting point is just calculating the contribution margin per unit of standard. $40 per unit minus a $20 variable cost is a contribution margin per unit of standard of $20. Deluxe, a $60 selling price minus a $24 variable cost is a $36 contribution margin per unit. So on the surface, you might say, well, we should produce deluxe. Each one gives me $36 versus $20 at standard. The problem is that they have a constraint, and the constraint is machine hours, and these two different models use machine hours much differently. A deluxe takes 3 times as much machine hours to produce. So we need to factor that into it by dividing our contribution margin per unit by the amount of the constrained resource. So standard, $20 in contribution margin per unit times 0.5 or a half an hour of machine hours equals every single machine hour produces $40 of contribution margin for standard. On the other hand, a $36 contribution margin for deluxe divided by 1.5 machine hours means an individual machine hour is only producing $24 in contribution margin if it's producing deluxes. So we flip this around in this situation. We would first want to go after standards because they produce a higher contribution margin per our constrained resource. So again, my maximum demand is 200,000. I'm going to go with producing standard first. Let me see if I can produce all 200,000 units. Let me test that out. 200,000 standards times 0.5 machine hours per standard will be 100,000 machine hours that I would need. That exceeds my 90,000 available, so I can't produce all of them. How many can I produce? I'll take that 90,000 machine hours I have available, divide it by the 0.5 machine hours it takes to make a standard. It means I can produce 180,000 units of standard. What's my maximum contribution margin? I know the problem doesn't ask it, but your exam questions might ask it, so it's good practice to do. I can do it one of two ways. I can say 180,000 standard times a contribution margin per unit of $20 is $3.6 million. Another way to do it is I'm taking 90,000 machine hours for my standard, multiply that times $40 per machine hour for standard, also equals my maximum is 3.6. Again, we can't produce all of the standards we want to produce, and we can produce no deluxes, but we are maximizing our contribution margin. Our B says, what if the maximum demand is 120,000? So let's look again how many machine hours that I would dedicate to standard, because I'm going to produce as many standards as possible, 120,000 of them, times 0.5 hours means we would spend 60,000 hours on standard. That's below the maximum 90,000, so we can produce some deluxes. How many deluxes can we produce? Well, if we had 90,000 hours and we spend 60,000 on standards, we have 30,000 hours left. Divide it by the 1.5 machine hours that it takes to make a deluxe, and we can produce 20,000 units of deluxe. What's the maximum contribution margin? 120,000 units of standard times $20 per unit. 20,000 units of deluxe times $36 in contribution margin per unit. And my maximum contribution margin, if the maximum I can produce is 120,000, is $3,120,000. So I want to add some extra things onto this, again, just setting you up in a good place, both for the real world and also the exam. And so let's assume, like part B, maximum demand is 120,000, but there is a possibility that Pappy's could rent a piece of equipment that would add on machine hours. What would we be willing to pay? Because there might be situations where we say it's our existing constraint is machine hours, but there is a possibility of relaxing that. So what additional units would we produce? Well, according to scenario B, we already maxed out standard. We have no more opportunity. So the only units that we can produce are deluxes. So my maximum amount that I'd be willing to pay to rent more machine hours is the contribution margin that I'm earning for a machine hour for deluxe. That's $24. Now, if I have to pay $24 to rent the machine, then my profit isn't increasing in that situation. I'm in a zero-sum game. But if I could pay $23, $22, or $20, I would gain additional profitability. Another item that I want to mention is just Excel Solver can be used to solve this problem. So let me pull this up real quick. Just did a simple spreadsheet here and just notating the contribution margin per unit, calculating that. Total fixed cost is 800,000, indicating the amount of machine hours per each unit, indicating here that the maximum demand under the current scenario of B is 120,000 units. And then I went ahead and built some formulas here. Like, for example, what is the total amount of machine hours? If I input a certain quantity for standard and deluxe, it would just multiply those quantities times machine hours per unit. I also have a formula here for profit. It's negative right now because I haven't input any production, so it's just my fixed cost loss. But it would take my contribution margin per unit times the number of units in yellow here, total contribution margin minus the fixed cost. So I can use the power of Excel. I'm just going to go over here under Analyze and click Solver. I have this already set up for ease of time of this particular video, and I know it's probably kind of small to be able to see here, but my objective is my profit cell, and I want to maximize it. What am I going to change? My two input cells that I have here highlighted in yellow, and that's the quantity that I'm actually going to be produce for standard and deluxe. What are my constraints? The quantity I produce for standard has to be less than the maximum of 120,000 units. The quantity for deluxe has to be less than the maximum, and my calculated amount of machine hours used has to be less than the maximum 90,000. So again, using the power of my solver here, it does come out to 120,000 units of standard and 20,000 of deluxe, and that agrees with our manual calculations that we did earlier.